Okay, so this question is asking us to write an expression to represent perimeter. And it's talking about a rectangle. So I like to draw pictures whenever I can. So I'm going to try and draw an ugly rectangle here. I know I'm using PowerPoint. I could probably just use one of the tools here. And it's telling us that the width is going to be called x. So we have to pick one of these to be the width. It doesn't really matter which one. Let's call this the width. So that's going to be x. And then the length of the rectangle is going to be 1 unit shorter than 1/6 of the width. So 1/6 of the width, well, that's pretty easy. That's going to be 1/6 of the width. 1/6 times x. But it's got to be 1 unit shorter, so we have to subtract 1 after that. So our length is going to be 1/6 times x minus 1. And then we have to remember, of course, what perimeter stands for, or what it means. Perimeter is the distance around a shape. So in this case, it's going to be talking about this width x, this 1/6 x minus 1, this is going to be x over here, and another 1/6 x minus 1. So there's our perimeter. We'll just take those things and add them up. So I'm going to say x plus x to take care of the two widths, plus 1/6 x minus 1. I'm going to put that in parentheses to show that it's one thing, plus 1/6 x plus, minus 1. The reason why I'm putting parentheses around there is with addition we don't really need to, but if there was going to be subtraction going on, then we would have to remember that we're distributing the negativity of subtraction, but don't have to worry about it in this case. So now we're just going to combine like terms. Well, first we have to take care of the parentheses, and we'll just kind of get rid of them. So let's see, because we don't really need them. So let's see, let's get all of the x's together. So there's an x term, there's an x term, here's an x, and here's an x. So we'll have x plus 1/6 x plus 1/6 x. And then we've got this minus 1 and minus 1. Whoops. I thought we'd be able to see through that, but I guess not. Let's see. Oh, it's painting. I'll just use the highlighters here. So we've got that minus 1 and that minus 1. So then we're going to have minus 1, minus 1. So let's take a look at all of this. And we're doing this because it's asking for a simplified expression. If it didn't ask for a simplified expression, we could have just left it long like this. But it's asking us to simplify it. So it means we really need to combine all terms, all like terms. So x plus x, that's going to be 2x because it's 1x plus 1x. And then these 1/6 x plus 1/6 x is going to be 2/6 x. And you know what? Let's simplify that a little bit. Those are both divisible by 2. So let's change that to 1/3. So I'm starting a new line here. And then minus 1 minus 1 is going to be minus 2. Well, we still need to combine these things. And we don't have to worry about the x's. We'll have to tack an x on at the end after we add 2 and 1/3. So let's just come up here and start a new thing here. So we're going to have 2x plus 1/3 x minus 2. So we've got to take this 2 and this 1/3 add them together. Let's get here. So 2 plus 1/3. Remember, when we're adding and we have fractions involved, we need to have a common denominator. But that 2 doesn't have a denominator at all. We have to give it a denominator. With whole numbers, we can always turn that into a fraction just by putting it over 1. Because remember, a fraction is telling us how many pieces we have of what size. So we've got 2 wholes, W-H-O-L-E-S. So that's the same thing as 2. So now we need a common denominator. Well, we can multiply this by 3 and multiply this by 3. Remember, whatever we do on the bottom, we have to do on the top. So we're going to get 6/3 plus 1/3. That's going to be 7/3. So now we go back into where we left off. Go back into here. And we're going to have 7/3 x minus 2. That is our simplified expression for the perimeter of this rectangle.